take to achieve? 1 moles in grams, right? It's just you got to know what magnesium chloride tetrahydrate is. What's magnesium chloride tetrahydrate? First off, is this ionic, covalent, or an acid? Say loud and proud. Ionic, why? Right, metal, non-metal. So what's magnesium? Okay, and if you say ionic, you must also say, what's the charge, right? Because I need you to make sure you're pulling charges first before you start throwing them together. Pull the charge, 2 plus, and then chlorine is, or chloride is chlorine. So Cl, 1 minus, crisscross, what do you get? And GCl2 is what I mean by crisscross charges. If I write CCC anywhere, it's just because you're not thinking about, is it ionic? Yay or nay? If it is ionic, you pull the ion charges and crisscross. And then tetrahydrate means how many waters? 4. And this dot here does not mean multiply. Okay, it just means it's there. 4 waters. How do I get the mass of this? How many of each atom do I have? 1 magnesium, that's 24.31 grams. Okay, plus 2 chlorines, that's 2 times 35.45 grams, plus 8 hydrogens, because that's not multiplied together, it's just this 4 times this 2, and this 4 times that 1. So plus 8 times 1.008 for hydrogen, plus how many oxygens? 4 times 1 oxygen, so that's plus 4 times 16.00 grams. That whole thing added together will be the entire molar mass of this, and you can convert it using your moles to mass, meaning molar mass conversion. So that was number 5. Just I think that was the only thing you really probably might get stuck on. What else up here? Give me another number. Say again. Number 2. So this one's okay. So this one's going to take us more than one step, and I know that because I'm going from formula units to grams. Is there a direct line between formula units and grams? Yay or nay, guys? No. So I know I can't go straight from formulas to grams, so I have to go from formula units to what first? Moles, and then they're from moles to grams. So basically, I'm up here in my little mole map. I'm up here at formula units. My grams are here. So from formula units to mole, I'm going to use what conversion, or what number? Good, 6102 times 10 to the 23rd. You've got this little map memorized. There's only 3 steps. There's only 3 branches. It's not too difficult. So that's our 6102 times 10 to the 23rd particles per mole, and then we'll go from moles to gram using what? Periodic table information. All right, so 8.92 times 10 to the 22nd. 8.92. 10 to the 22nd, formula units of what? What is this question? Ooh, formula. Okay, formula units of aluminum nitrite. First off, ionic, covalent, or acidic? Ionic, because it starts with a aluminum, which is a metal here, right? So what is aluminum nitrite? Ooh, we see the I ending, right? What does that I ending tell me? Okay, so poly, but I dropped the O from the 8 version. So you've got nitrate memorized. What's nitrate? NO3, -1, so what's nitrite? NO2, -1. Okay, so crisscross this aluminum, Al charge, 3 plus, and then nitrate, NO2, 1 minus, crisscross. What's your formula? Al, parentheses, NO2, parentheses, 3. Beautiful. Okay, so we're starting to mesh these together, right? All right, so you guys told me the first step was to use Avogadro's number. Where do I put Avogadro's number? Top or bottom? Say again? Bottom, because that's referring to number of particles. Well, formula unit is just a style of particles. 61022 times 10 to the 23rd. Formula units of aluminum nitrite are equivalent to 1 mole of aluminum nitrite. And I have to put my parentheses because if not, it'll look like 23. All right, so then from here, formula units of aluminum nitrite and formula units of aluminum nitrite go away. And then so where am I at on my mole map? I'm at the middle mole, right? So I'm off my branches. I'm gone from the top branch to the middle. Now I'm going from the middle where? To grams. Okay, so that last step, what is going to go on the denominator over here? 1 mole of this guy, aluminum nitrite. So when you add up aluminum plus how many nitrogens? Say again? 3 nitrogens and how many oxygens? 3. Oh yeah, 6. I'm not bad. I was going to throw it was a 3. So my handwriting. So 3 times 2 is 6. So 1 aluminum, 3 nitrogens, 6 oxygens. What's our total mass? I believe you. Thank you. 165-ish grams per mole. Aluminum, nitrite. Okay. So in your calculator, big number divided by, what do I have to do with this to make it perfect when I calculate? Put it in parentheses. If not, it's going to say that number divided by 6.022, and it's going to say the whole shebang times 10 to the 23rd. You want it to stay in the denominator, so you have parentheses there. The little evil blue calculators are not my favorite, but if you don't bring one, that's what I have to give you. It's a little hard to see that sometimes. All right, so when you divide, you're going to get probably like 1.2, 1 point something, because that's 22, that's 23rd, or maybe you might get like 0.1, something small. And then times 165, what is it, like 17 something? Final answer? 24, you know, rounding error, 24.4 grams of aluminum nitrate. And that does go with correct sig figs, so we're good here. All right, so I'm going to pause. You guys keep rolling. I want you guys to finish up 1 through 5, and then look for another one that you think would be beneficial for you to practice, especially if you feel good about just like talking to yourself through the steps, like, oh, I know how to do this step, I know how to do this step, I know how to do that step. Practice the nomenclature involved as well. But I want you to just keep getting some visualizations of what is your problem solving process.
Could you just divide 42 minus 6? What's the mass to be? I know 1 to 72. What's probably 1? Great. Did you get 4.08 times? Because it'll be 0.678 times 10 to times 6.02 times 10 to 23.
That's what it equals. 4.08 times 10 to 23.
You got 4? No, no. Margin. This would be 2 steps, right? 4. Yeah. I'm gonna go to 6. I'm gonna do the like multi-step ones because I can get the most easy.
All right, what number are you guys on? Who's done with 1 through 5? All right, who's done 1 through 6? Okay, cool. I want to make sure I'm giving you a chance to keep absorbing some of the information. Who's taking the ACT tomorrow? Okay, so since our quest is Wednesday, I want to give you guys a chance to ask me some questions. I'm going to start with 1 or 2 examples from the homework, because there are a couple nomenclature or like faux pas that you're still letting yourself just fall into, okay? Before I do that, any questions on 1 through 5 here? On process. It's more about process, because if you can't calculate, I'm not going to help you with the calculator. You got to figure it out. Process? Yeah.
You're taking questions on the lesson that's not 1 through 5.
Let me start with 1 through 5 for a moment. Before I move on, then tell me the formula for iron 3 carbonate, number 3. Fe2, CO3, parentheses, 3. Thumbs up if you got that. Okay, there, and that's what I was just talking to somebody else. If you just look up stuff online, you're not forcing yourself to walk through your process, and if you don't practice your process, you don't know your process, period. And I had somebody ask me, like, why do I assign the work that I assign? Because you guys don't always know where to go for resources, and half the time you might spend more time looking for resources than actually looking at the resources. So if I give you the resources, aka like what I expect, you don't have to hunt. You don't have to waste your time hunting. You can just focus on what I want you to focus on, which I've been doing this for a while and I know it works. So work with me here, okay? Carbon dioxide, I know you got this one. CO2, it's ionic, covalent, or acidic. Covalent, you name it as you see it, there's no question. We already did that one. Copper 1 carbonate, ionic, covalent, or acidic? Ionic, because it starts with copper, and it's got a big 1 in it. What's that mean? Charge of who? Of copper. Okay, so then full on crisscross your charges. What is the formula? Cu. 1, right? Okay. Cu2, CO3. Where's that 2 coming from? The carbonate. Calcium iodide. Hold on, pause. Ionic, covalent, or acidic? Just make sure you're classifying first. Ionic, because it's got a metal, which is calcium, and a non-metal, which is iodide. What's iodide, though? It's just phenyl iodine. Okay, tell me what the formula is. CaI2, because calcium is a 2 charge, iodine has 1, crisscross. Some of us have probably looked at the periodic table 1,000 times and just remember, oh, it's in group 2, oh, it's in group 7, but I don't expect you to do that all the time. I expect you to double check yourself, because you can easily say, oh yeah, nitrogen's in group 6, it's got a 2 negative charge. No, nitrogen's in group 5, it's got a 3 negative charge. So don't let yourself just like not look at the periodic table. It's there for you. Yeah, when it says liters of oxygen gas, this means diatomic, which is O2. FYI. There's only like 2 like that right here, oxygen gas. And then cobalt 2 dichromate. Cobalt 2 dichromate. Ionic, covalent, or acidic? Ionic, so cobalt. 2, where's this 2 coming from? 2 of who? I'll put the 2 plus up here, okay? And let's write out dichromate. Cr2O7, parentheses, 2 minus charge. You've memorized chromate, same, very similar to dichromate. Crisscross. Okay, so CO, Cr2O7. The 2's reduced because that's the, what's the thing where you reduce? Empirical formula. Thank you. Okay, so that's the empirical formula. Everything ionic gets reduced. All right, so on your homework though, there are a couple that I saw some issues with. What is lithium nitride? Number 18. Lithium nitride. Li3N. Where did I get that 3 from? From nitrogen's charge, crisscross. I see it as ionic, right? How about sodium sulfite? Sodium is what? Na. Sulfite is 1 less than sulfate. So what's sulfate? SO4 charge 2 minus. You got these memorized, okay? So sulfite is SO3. Where does my 2 minus go? Crisscrosses down. The 1 plus goes down here. We just don't write it. Okay, so that's number 31. Thank you. Oh, I skipped one. 7, aluminum acetate. I'm telling you, if you look these up online, they start to jumble the letters together because they basically pull the C's together and the H's and kind of messes up your world here. Your world is ionic, in this case, because it starts with aluminum. If I start with aluminum, I have to find the charge of aluminum, which is 3, and then acetate is like the only polyatomic with 3 letters. Charge, -1. Crisscross, Al, C2, H3, O2, 3, because that 3 gets crisscrossed down. Okay, so when I say acetate, 3 syllables, 3 letters, it's only polyatomic really with that. How about cobalt 2 oxalate, which is 34. Cobalt 3 oxalate. Cobalt is what? CO. It's got a charge of 3 plus. Okay, so I'm actually going to write my charge here for a moment. Oxalate, weird polyatomic. I'm ready when you are. C2O4. Here, I don't know if I told this class or my other class. I think of this as an ox with 2 ears and 4 legs. Yeah, 2 legs, 4, or 2 ears, or 2 horns and 4 legs. I thought it was cute. Okay, well, what's oxalate's charge? 2. Crisscross, what do you get? CO 2 C2O4 3. Okay. All right. So any other on the on the nomenclature ones for now that you guys had issues with? 1 through 34. I can talk to you later about it too. It's cool. Okie dokie. Couple on the bonding section. Okay, on that little number 5 where it had like Cl2O dot structure, what was the first step that you have to do when you're drawing structures? Count valence electrons, right? So then this is kind of old stuff, but it's still pertinent because it does kind of reflect your nomenclature. So that's dichlorine monoxide. So we count up its valence electrons. How many are here? 2 times 7, right? Because chlorine's in group 7 plus 6 electrons total. 20 electrons. Okay, so what goes in the middle? The O, and then on each side, a chlorine, and on each of those chlorines we need. So octet, 2, 4, 6, 8. 2, 4, 6, 8. What about this oxygen? 2, 4. Okay, so if I count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, score, I got my 20. And then from there, you have to think about what now this one didn't ask for shape, but you could easily maybe figure it out. I have 2 arms, and I have a lone pair here and here. But remember, the lone pairs can just cause some sort of repelling and pushing. Anybody have a guess on that shape? It is bent, right? It's not linear, actually, and you guys had your sheets, or from my website, the section is a bent structure. So if it is bent, and it is, looks kind of like this, like water does. There's our oxygen, 2 lone pairs, and chlorines. What would you say about its polarity? Is there an equal distribution or an unequal distribution of electrons? Unequal. So unequal means polar or nonpolar molecule overall. Polar molecule overall, because if you have a end that's partially negative, and then this end's kind of partially-ish positive just because it doesn't have the extra lone pair. So if it's polar, which of the 3 intermolecular forces can it experience? Dipole, or hydrogen bonding, if that were the case. But in this case, I don't have hydrogen bonded to a highly electronegative element, so I don't even have hydrogen, right? So this one's just going to experience dipole-dipole interactions. And that's on the second chart. Yeah. So that walks you through one example there. I'll do one more of these. Do you guys want me to walk through one on number 5 or one on number 6? I'd rather do one that you want to do. Can you give me a sample? I read from number 6. Give me one, man. Somebody give me one number 6. Name it, boy. Come on.
Carbon,
tetrabromide. Thank you. CBr4. CBr4. Carbon has 4 valence electrons, because in group 4. Each of these bromines, there's 4 of them, but each carry 7 valence electrons. Okay, so what's that total? 32. If you are cool with watching, that's fine, but if you're gonna write down your steps of your thought process, that's really what I'm trying to support you with, is the process. So after you see your formula, you get your valence electrons. After you get your valence electrons, you plop what in the middle? Carbon, and then you append your 4 ligands or 4 other atoms in a symmetrical fashion. Done. Then give everybody octet. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Does carbon have octet?
Yeah.
Already, it just happened to because of the 4 attachments it had. Total electrons, 8, count with me, 16, 24, 32. Good, I have 32, right? Cool. So after I have my structure, I didn't do the bond polarity part. On your electronegativity sheet, it has carbon electronegativity and then bromine's electronegativity. So does anyone have the little sheet right in front of them? There's probably one. It's like 2.5 and I don't know, 3. Maybe bromine's 2.5. I know there's one. Caleb has it back there. 2.8. Okay, so 2.5 and 2.8. So that difference is 0.3, which is our electronegativity difference. Not very much a difference in their electronegativity. So would you say that the electrons in this bond here are equally-ish spread out between carbon and bromine, or they push towards one side or the other? Probably equal, because there's not one pulling it back and forth, so it's fairly equal. So if I think about the distribution of charge all the way around in like a north, south, east, west, kind of think of the globe, what would you say about the distribution of electrons? Equal distribution. Okay, equal distribution means what kind of molecule as a whole? Nonpolar. If nonpolar as a whole, which IMF does it have to experience? London dispersion only, because you memorized London dispersion goes with nonpolar, and that's not very strong, but this bonded to another carbon tetrabromide will attract each other slightly. Okay? So I'll take some more individual questions in a bit. We're going to switch modes here. Okay, so we practiced nomenclature. We practiced just basic mole conversions. The only thing we haven't touched yet on is empirical and molecular formula. So put your CSI hats on. There's been a murder. Oh my gosh. Okay, I can't get my CSI tape undone. Okay. Woo! There's been a murder. We have to cover up our scene. I really just want to do that. Okay. So you guys have a couple of things for me. You have this dead guy on the floor. I don't know if you've seen him. And he's been there for like 3 days. And still haven't solved the crime. Okay? He had this like little exciting pose when he fell and died. So you're looking for him. Good training. So the victim for the following case is a 35-year-old white male named Tony DeMoy. Initial investigators say they found several signs around the death sites that look at foul play. 4 possible causes of his untimely death have suggested his wife, who has been ruled out as a suspect because of proven alibi. Your task is to identify who and what killed Tony DeMoy. So we have one case with an unlabeled drug bottle. We also have a little cup that was found in the scene. Possibly it was contaminated with something not so great from his disgruntled neighbor. We have his wife, who she had some problems and she had some pills, and he could have popped some of those pills. And then we also have his lab assistant, because he was a brilliant scientist. Maybe he wanted a little something for his work, and the scientist didn't want to offer up. So we don't know, but it's up to you to figure it out. So you have to be timely in your solving of this case, because you have about 35 minutes to solve your case. Okay? And in solving your case, you have 3 brilliant minds with you. One person is the liaison who can come and ask me questions. The other people are hard workers. Okay? Everyone's going to be writing this down on their paper. They have paper out? They have paper out to document their investigation. Okay, so I'm your boss. I am the keeper of the autopsy report. And the autopsy report has spelled out exactly how he died, but I need your investigation to be complete first before we can kind of fulfill that. So communicate with people at your table that you choose. I don't have name tags for you today. It was cool. So maximum 3 groups for 3 people per group. And come and grab an investigation from me. Let's roll. Come to the lab station. I'm going to talk to you on the lab station.
I don't know how many times I said something like
And I will say, first people to solve the crime and it's correct, I'll give you more money. It's extra credit dollars.
Okay.
More money, more problems. You have three, choose the three people in your group. Choose the three. Choose the three people in your group. Don't step on your crime scene. Alright, so as I spread this out, yes, there's some extra papers over here, some extra papers over there. Choose your three people for group. You're good. Alright, so you'll see all the juicy details of the case are provided on this paper in front of you. And to be honest, this is not a divide and conquer kind of deal. This means you guys all can start one of the prompts, but you need to talk through it to practicing the process. Just because one person knows how to do something doesn't mean you know how to do it. So support each other.
I wanted you guys to have that done. You had all day on Friday, and I just need the evidence of work.